Hi everybody, welcome back. This is notes number 44 and we're continuing in chapter 8, multiplying and dividing rational expressions today. So go ahead and get yourselves ready to take some notes. We're going to start by thinking about how we multiply and divide rational numbers, aka fractions. So take a look at my first example here. We know that what we do to multiply fractions is we multiply the numerators, so 2 times 3, and we multiply the denominators, 7 times 5, and that would just give us 6/35. Okay, so there's no need for a common denominator when you're multiplying. Now suppose you had something like the second one. You could just multiply the numerators, 200 times 21, and multiply the denominators, 49 times 500, and that would give you 4,200 over 24,500, but the problem is then you have to reduce it, and you've just made it difficult on yourself to reduce by multiplying the numbers first. So that's not what we want to do. Instead, what we want to do is factor first, reduce, and then when we're done, multiply what we have left. So you could think of 200 as factoring into 2 times 100, and we still have the times 21, although you could think of the 21, kind of anticipate what's about to happen. Look at the denominator. Factor the 21 into 7 times 3, and you want to do that because 49 factors into 7 times 7, and then factor the 500 into 5 times 100. Now, of course, we could break down the 100 more on the top and the bottom, but you just kind of look at what you need to do, look at what's on the top and what's on the bottom, look at what you need to do to reduce it easily. So from here, we could cancel the 100s, and we could cancel one of the 7s on the bottom with the 7 on the top, and then when you're finished reducing, you can multiply what you have left, and we have 6/35. Okay, now how about dividing? Remember that dividing by a fraction is equivalent to multiplying by the reciprocal. And when we say by the reciprocal, we're talking about the reciprocal of the one that's after the division sign. So we change the problem to 6/13 times 39/16. And then from there, it's just a multiplication problem. So you do exactly what you do on the previous problem, which is, if possible, factor, like the 39, we would factor into 13 times 3, and I should factor the 6 as well. Factor the 6 into 2 times 3, and the 13 on the bottom doesn't factor, and we could factor the 16 into 2 times 8. We could factor it more, but we don't need to because we're looking at what we have on the top, a 2. Cancel that with a 2 on the bottom. Look at the 13 on the top and the bottom, cancel those, and then what we have left is 3 times 3, 9/8. Okay, we're going to apply all those same concepts to rational expressions. So remember, anytime you're dealing with rational expressions, you should use the same types of moves that you would make with rational numbers. So we're going to work through 5 examples, I think. Yeah. Okay, so here's the first one. You can go ahead and pause whenever you need to so that you can write things down and think about it. So we're multiplying the numerators and we're multiplying the denominators, but perhaps we would like to do a little bit of reducing first. So let's see here. Maybe we want to think of x. Well, let's factor the numbers and then let's combine the x to the 5th and the x to the 1st together. So we have the 3, and then from the 6 we have a 3 times 2, and then x to the 5th times x is x to the 6th, and then y squared times y squared is y to the 4th. Now this is not the only way to think about it. There are multiple ways to think about it. This is just my choice this time. And then on the bottom, let's factor the 8 into 4 times 2. Now you could factor it more, but I don't think we need to because we have that 2 on the top that we can cancel. And we can factor the 9 into 3 times 3. And then we have x times x to the 3rd, so that's x to the 4th. And we have y times y, so that's y squared. Okay, now let's look at the coefficients. And let's cancel a 3 from the top and the bottom, and another 3 from the top and the bottom, and the 2 from the top and the bottom. And now we can use our exponent rules. If we have x to the 6th on the top and x to the 4th on the bottom, we subtract those exponents. So now we have x squared on the top. And if we have y to the 4th on the top and y to the 2nd on the bottom, we subtract those exponents. So we have y to the 2nd on the top, and then we have 4 still on the bottom. Okay, let's take a look at number 2. So notice that what we did on number 1 was we were canceling factors, and just like in our last lesson, if you want to cancel or reduce, you have to cancel factors, not terms. So let's work on factoring the numerator and denominator of the first fraction here in number 2. So let's factor out a 2x, and that gives us 2x times the quantity x minus 5. And we also have the quantity x plus 3. We might as well just put those all in one numerator. And then on the bottom, we can factor 25 minus x squared. That factors into 5 minus x times 5 plus x. And then the 2x squared, we could think of that as 2x times x. Because if you look at what you have on the top, a 2x, then it's nice to have the bottom with a 2x as well. Okay, remember what we learned in our last lesson about x minus 5 and 5 minus x. Those are opposites, so if you want to cancel them, you need to leave a factor of -1. When you divide opposites, you always have -1. And we can cancel the 2x from the top and the bottom, and then take a look, see if there's anything else you can do. Doesn't really look like it. So we could write our answer like this: the opposite of the quantity x plus 3 over x times 5 plus x, or x plus 5, however you want to write that one is fine. If you want to distribute the negative sign through the numerator, you can. If you want to distribute the negative sign through the denominator, you can. If you just want to write the negative sign in front of the whole fraction, you can. There's a lot of different ways to do it that are all perfectly fine and acceptable. You just need to know, if you do it differently, whether or not your answer is equivalent to the answer given. Okay, let's move on to problem number 3. All right, so we have a rational expression multiplied by a polynomial, but you could think of that polynomial as just being over 1. So there you have a fraction times a fraction. And let's go ahead and do our factoring and then see what reduces. So we have x plus 5, and x squared plus x plus 1 does not factor. And then in our first denominator, we have x cubed minus 1. That's a difference of cubes. And we have a formula for factoring a difference of cubes, and that factors into x minus 1 times x squared plus x plus 1. Okay, so notice we have a common factor on the top and the bottom. Cancel that, and what we have left is x plus 5 over x minus 1. Remember, you cannot cancel these x's, because that's canceling terms, not factors. And remember, if you're ever tempted to do that, all you have to do is plug in a number and see what happens. If I had 1 plus 6 over 1 minus 1, well, that maybe I don't want to use a 1. That brings up a whole other issue. Let's say I had 7 plus 5 over 7 minus 1. If I plug in 7 for x, that should be 12 over 6. But if I cancel the 7's, it's no longer 12 over 6. It's an order of operations problem if you do that. So leave it as it is. Okay, moving on to number 4. Now we're getting into division. Remember, what you want to do first in a division problem is change it to multiplying by the reciprocal. So the first fraction multiplied by the reciprocal of the second one. Now it's simply a multiplication problem. And what we want to do is factor and see what reduces. So we have 4 times x. By the way, you don't have to write it as 4x. If it helps, you can think of it as 4 times x times whatever comes next. That way you know that 4 is a factor on its own and x is a factor on its own. They're not glued together. Now let's factor x squared minus 6x plus 8, and that would be x minus 4 times x minus 2. And on the bottom, we can factor a 5 out of the first denominator. So we have 5 times x minus 4. And then we can factor an x out of the second denominator, and we have x times x minus 2. So let's see what cancels from the top and the bottom. We have an x on the top and the bottom that we can cancel or divide out, as your book likes to say. A lot of times we're not officially supposed to say the word cancel. We just do that casually. Divide out an x minus 4 and an x minus 2. So all we have left is 4/5. Okay, let's move on to the final example. Here's number 5. And like one of the previous examples, our second part, I guess I'll call it, is just written as a polynomial. So you could write it over 1 and make it look more like a fraction. And because we're dividing, we're going to rewrite this as the first fraction multiplied by the reciprocal of the second. And next, let's factor everything. So let's see what 2x squared plus 3x minus 5 factors into, if it even does. Let's check that out. Suppose we put a 5 there, and a 1 there, and a plus there, and a minus there. Yep, that works. Okay, and then I'm anticipating that I can just leave my 6 as a 6 and not factor it anymore. And then with the second fraction, we have our 1 on the top, and then it looks like we could factor an x out of the denominator, and the other factor would be 2x plus 5. So let's see if anything cancels. We have a 2x plus 5 on the top and the bottom. That's about it. So what are we left with? X minus 1 over 6x squared. Okay, great job, everybody. That's the end of that lesson. And your assignment is 8.4 Part 2 from page 578. Last time we did 8.4 Part 1. So what you can do is once you're done with both, turn them in together on Google Classroom. And remember to show your work, check your answers, and if you don't have access to a book, I have put an attachment with all the problems as well as the answers on Google Classroom. And of course, always let me know if you have questions.